Today we're going to look at the final day of Learning Target 23, dealing with systems of equations with substitution, and we're going to talk about systems of equations that have special solutions. Now last week we talked about identifying types of systems where they were consistent, inconsistent, and then if they were consistent either dependent or independent. And we also talked about the number of solutions, whether it be 1, 0, or infinite. Now today we're going to look at how, if we aren't graphing it and we're using substitution, we're going to be able to tell these things. So we'll start with step 1, which is to solve them by substitution. So we'll go ahead and do that right away. And I see that I'm going to start with this equation here, and I'm going to solve it for x because x has no coefficient. So I've got negative 2y equal to x minus 6. I'm going to add 6 to both sides. So I get that negative 2y plus 6 is equal to x. And I'm going to box in that 2y plus 6, and I'm going to box in my x in the other equation. I'm going to scroll this up a little bit so you can have some room to work. And so then we have 3 times x, which is negative 2y plus 6 plus 6y equal to 18. And I'm going to distribute. So I get negative 6y plus 18 equal to 6. Oops, sorry, not equal to. Plus 6y equal to 18. And when I see here I got negative 6y plus 6y, those cancel each other out, leaving me with 18 equal to 18. Now you're going, crap, what do I do now? So we're going to take a look at if all the variables cancel, which ours did, and the equation, what the equation looks like. If the equation is true, which in our case 18 does equal 18, that means we have infinite solutions. I know a lot of you are going to want to go 18 equals 18, my solution is 18. But if the variables drop out, that means that anything will work in those variables to get it to be true. Which means that our solution here is we have infinite solutions. Now on the other hand, which we'll see some examples today, if the statement is false, say it had been 16 equals 18, then it would be no solution. So now let's take a look at this example. We have 4x plus y equals y plus 4 and y plus 5 equals 4x. So I'm going to go ahead and work with this second equation again. I'm going to take y plus 5 equal to 4x, and I'm going to subtract 5 from both sides, giving me y is equal to 4x minus 5. I'm going to box in that 4x minus 5, and then I'm going to box in the y on the other equation. So now I have 4x equal to y, which is 4x minus 5 plus 4. And I'm going to first combine like terms to get 4x equal to 4x minus 1. Then I'm going to subtract 4x from this side, because I need to get variables on the same side. I know you're inclined to add 1, but that's not going to do you any good. Well, this ends up canceling to 0. These cancel out, giving me negative 1. Well, as we can see, just like we were talking about, 0 does not equal negative 1. So that means we have no solution. You can also write 0 to /0, which actually means the null set, and null means nothing.